Hey everybody, morning or afternoon, whenever you're watching this video. I got a pretty big one for you today. I'm going to go over a lot of stuff, and it's going to seem really confusing, but I promise you it's not as bad as it looks at first. So we're going to go over what's called points of concurrency, right? What that means is there's a bunch of different lines you can essentially create in triangles that have different properties. The nice thing is that I've got this handy dandy chart here. Let me show you real quick. It's a handy dandy little chart that's going to be posted with your quiz, of course. All right, there we go. And we're going to go over it extensively. Let me save. Points of concurrency. All right. It's going to be on your quiz, right in front of you. And then we're going to look at it here, and I'm going to go through it in its entirety. It looks nice and easy. It is. If you refer to it over and over again, it is. But we're starting to get to the parts of geometry that are, frankly, harder. A lot of these things are going to be pretty difficult, but we'll get through it together. Don't worry. I'll do the hardest parts with you, and we'll figure it out. So, of course, I'm getting a phone call, but that can go to voicemail. All right. That's the first phone call I've ever had during one of these videos. I hope it's not important. So, let's go through this one at a time. So we've got ourselves a triangle here. It's an acute triangle. You can tell that because all the angles are, 90 or less than 90 degrees. So we're good there. So let's go through what these mean. I didn't do a great job snipping this, so it doesn't have the actual important stuff on it. Let me do a better job real quick. Hope you all are doing well. All right, there we go. File, save as, points of concurrency. There we go. Much better. No, not what I wanted. Come on, man. There we go. Okay. So we're going to focus on, I'm going to cover these up and just do one at a time. How about that? So there are 4 points that we need to talk about. I'm going to try and do these decently fast because I don't want this video to be infinitely long. But it's probably going to be a long one. But we've got the name of the point being created, the line used to create the point, and then special properties that that point has. So what I mean, or what they mean essentially, is that a circumcenter is created by perpendicular bisectors, which I'll explain, and has these properties. It's equal distance from all 3 angles and the center of the circumcircle. So I'm going to explain all of that in a second. Also, fun fact, circum in Latin means circle. So the center of the circumcircle in Latin would be the center of the circle. Whatever. All right. So what is a perpendicular bisector? Well, a bisector means to cut something in equal halves. So cut something in half, and those halves are equal. Bisect, cut it in equal halves. Perpendicular means, well, 90 degrees. So if we take this triangle right here, this acute triangle, and we cut it in half, and this isn't going to be exactly precise. I'm over here using my fingers on my screen right now to estimate the midpoints, but it's fine. We're going to draw a line coming out of the triangle. And I'm going to say that this side equals this. Now these notches means that from this point to here is equal from here to this point. So this is cut in half, it is bisected. I'm also going to say that right here is a right angle. This is a perpendicular bisector. It is cutting the side in half, and then this line that is cutting the side in half is also leaving the triangle or leaving the side at a 90-degree angle. That is a perpendicular bisector. So how does this create a circumcenter? Well, frankly, by doing it 2 more times. Really, you only need to do it 1 more time, but you'll see. So if I take the bottom here and I find my midpoint, should be right about there, and I come up to my best degree right there, boom. So we're going to say this and this are equal. Well, we're going to say that this is equal to that side. We're going to say that this is a 90-degree angle. Cool. Notice that they cross on a specific spot. Well, if I did this really well, which I have a tendency to, well, not always do it really well, but this is not bad. I think we're going to say this section here is equal to this section. We're going to say this guy is a 90-degree angle. Cool. So if we do all of that, there is a single point where these 3 lines will connect. Right there, right? That point is going to be our circumcenter. By the way, I type much faster than it seems on these videos, but my mic is in the way of my keyboard, so you know I'm not exactly like Twitch streaming here, so give me a break. But this point right here is the circumcenter. So that's what we mean by name of the point created. Well, a circumcenter is created by the crossing of perpendicular bisectors. So when you cut the sides in half and leave them at a 90-degree angle, all 3 of them on the triangle are going to make a 1 point, and that point's going to be called the circumcenter. And it has 2 special properties. 1, it is equal distance from all 3 angles. Right? So this point right here, how do I want to do this? I want to draw more lines on the triangle. There's so many lines on this triangle. Whatever, let's do, I can't do a dotted line. That's what I would do in class. But so the distance from the circumcenter to this angle, from the circumcenter to this angle, and the circumcenter to this angle are all equal. All the blue lines are equal to each other. That's what this is saying, equal distance from all 3 angles. This point is always going to be equal distance from the 3 angles of the triangle, regardless of if the triangle is acute, obtuse, or right. That's always true. And then this second part, this center of the circumcircle, this one's gonna be fun for me to do here because I've never done it like this. Oh, this is gonna be fun. This is really difficult. All right, so a circumcircle is something that we never have to deal with in geometry, thank goodness, or at least you guys don't. We don't do this, but boom, that wasn't too bad. So the circumcircle is a circle that goes all the way around the triangle, touching all 3 points. The circumcenter is the middle of that. It's always the center of that circle. That is not a very important aspect of this. The equal distance from all 3 angles is way more important, which is why I put it first. But the reason why I mention this is because sometimes on tests, especially like the final exam, they're 100% going to be like, hey, which point is the center of the circumcircle? Well, circumcenter is the center of the circumcircle. Should be decently obvious, but I understand if that's confusing. So that is circumcenter. Thing is, though, that's circumcenter in an acute triangle, which is why this video is going to be pretty long, because circumcenter changes drastically depending on the kind of triangle you have. For instance, if we sling a right triangle over here, we're going to get something, or a couple of things that are a little different. So let's do, can I do a box? That would be nice. Hey, all right. So this is the right triangle. It's got a right angle right there, so on and so forth. What we're going to do is the exact same thing. We're going to cut this side in half and this side in half and show you where the circumcenter would land on a right triangle. So I'll draw this out, hopefully at a right angle. I'm not too bad at eyeing things. All right, so that's going to be a right angle. This side is going to equal this. And then we're going to go here. Draw our right angle there. My picture is not perfectly to scale, as I am noticing, but it is fine because it'll show, it'll be like this, you know, if I did it correctly. So right here is your circumcenter in a right triangle. When you cut the left side, or when you cut the two 90-degree sides in half, their perpendicular bisectors are always going to land somewhere on the hypotenuse. They're always going to be on the triangle. So in an acute triangle, it's in the triangle, the point. In a right triangle, it's on the triangle or on the hypotenuse. I don't know if I can get a circle big enough to show you the circumcircle here. Let's see here. No, don't draw another one. Give me access to this one. And ooh, okay, there we go. Oh, this is going to be interesting. I don't know if my screen is big enough. Oh, God. All right, so I got most of them. Let me get over here. Let me bring this down. And that over. Yeah, there we go. For the most part. Yeah, that's what the circumcircle looks like on the right triangle. It's pretty big and out there and all that stuff. But all you really need to know is that the circumcenter is on the hypotenuse of a right triangle. All right, let's clear all that and then look at obtuse, which is by far the weirdest one when it comes to circumcenter. An obtuse triangle. Right, obtuse triangle is where, you know, one of the angles is greater than 90. The other two are going to be tiny. So if you're catching the gist here and you're like, hold on, if a 90-degree one, the circumcenter was on the triangle, it kind of moved. In this one, it's going to be, well, it's going to be kind of far away. We're going to do this that way. I'm going to draw this pretty far just in case. You should see me do this on a whiteboard. It's pretty fun. I mess up a lot. I am not an artist in the slightest. So working on a mouse and keyboard hasn't exactly improved my artistic talents at all. Actually, it might have, because these lines are straight, mostly because the computer does it for me. I have to use a ruler in class. All right. Did I do that right? I think I did that right. Ooh. And then we'll do... All right. That is the circumcenter in an obtuse triangle. It is all the way out there. It's all the way out there because the circumcircle extends super far out from the triangle. And I don't know if I'm going to pull this one off either. We'll see. We'll try. Again, like the whole circumcircle thing isn't really necessary, but I'm just being, I don't know, giving you the knowledge. That's almost right. It would touch all three. I'm having a hard time manipulating this to do exactly that, but I think you get the idea. Right? It would touch all 3 points, which I'm sucking at right now. And it would be sticking out real far, and this would be the center of the circle. So, again, that's not really the important part. The most important part is, by far, that it is equal distance from the three angles. And I'm going to show you some problems based on it, but I just wanted to explain the notes first. So, all right, let's move on to in-center. I won't have to do as much now, I think. I think it'll be easier. All right. So, in-center is created by angle bisectors and is equal distance from all three sides. This one is nice and simple. If I have angles here, like so, and then I did lines that cut them directly in half. And say there, we'll say here, and we'll say there. That'll be good enough. All right. That, at least, oops, no, other one, there we go. This point right here is your in-center. So in-center is equal distance from all three sides. All three sides. So the blue lines I'm going to draw, right? I'm going to go from this point straight to the side. I'll go from this point straight to the side. From this point straight to the side. All those blue lines would be equal to each other, which means I messed up that in-center, didn't I? Because that is not equal to that one. That's going to bother me. It's fine, though. You get the idea, I think. Right? I say that, but now I want to redo the whole thing. But let's see if we can get it more accurate, because I'm ridiculous. It should, in an acute triangle, it probably should be pretty close to the center. Cut angles in half. By the way, it's really difficult to cut angles in half by sight. So don't be getting on to me for that. All right. So in center, that looks a lot better. And it is going to be equal distance from all three sides. If I went from here straight to the side, from here straight to the side, that looks so much better. And then from here straight to the side, they'll be equal distance. They'll all be the same length. Nice thing is in center stays in the triangle, because if you're cutting angles in half, then you're going to stay within the triangle, right? You're going from the angles inside into the triangle. So really all you need to notice, all you need to look for is, are the angles bisected? Are they cut in half? They can do that in two ways. They can do this, where they have one arc and they show it like that with two notches saying this angle is equal to that one. Or they can have multiple arcs, like so, saying this angle is equal to this one. Those are the two ways they would show it. Of course, more notches means, different. And then same here, more arcs would mean different. Ooh, that one's messed up. Let me redo that. There we go. So this angle equals this one. This angle has two arcs. This one has two arcs. Those are equal. This has three. This has three. Those are equal. That's how they would signify angle bisectors, or the angles are cut in half. Let me do one other triangle for in-center. Do I need to? I guess I will real quick. All right, real quick, we cut the angles in half. All right, we got this one. We got that one. And then, of course, we've got the right angle. There we go. Cut that in half. Cut that in half. Should look like that. And cut this in half. And then the point where they meet up is your in-center. So it doesn't change drastically like the circumcenter does. It's pretty straightforward. Like it's in there in the triangle. Cut the angles in half. Easy peasy. So let's move on to orthocenter. Orthocenter is the easiest one because it doesn't have any special properties. It's not special, right? It doesn't get to be special. So orthocenter is made by the altitudes of a triangle, also known as the height of a triangle. Now, most of you, of course, know the height of the triangle as you go to the very top, you draw a line straight down, right? It's going to form a 90-degree angle with the bottom here. It'll form a 90-degree angle with the ground. And then, right, you're done. That's the height of the triangle. So how do you get multiple heights of a triangle? Well, if you imagine for a second, I took this triangle and I rolled it over. Ooh, what's happening there? That's not what I wanted to do. Is that? Uh-oh. Where is that coming from? Uh-oh. What is... Oh, no. What is happening? Having all kinds of difficulties today. All right. There we go. Cool. All right. So imagine, back to what I was saying. Imagine you took this triangle and you rolled it over. Like, you know, like you would a block, like a block of wood that's shaped like this. You would just tip it over, right? So now this is the bottom. This side on the right is now laying flat. Well, you would have a new point, right? You'd have a new point that you could then call the top. And so then you would have a new height, theoretically. You would draw a line from this side straight down to a 90-degree angle on the other side. That would be the height on that side. Notice how I'm not putting any notches on the sides here, because these are not midpoints. I'm not cutting the sides in half. I'm drawing a line from an angle straight down. So that is something that you should pay attention to, hint, hint, wink, wink. That'll be important, but yeah. So from an angle straight down to the side makes a 90-degree angle. You're good to go, and that is your orthocenter. It has no special properties whatsoever. Nothing. It's just like, you know, well, if you drew multiple heights in a triangle, what would you get? You'll get an orthocenter. What does that do? It's there. That's what it does. Again, for tests and everything, these kinds of questions would literally just be, what kind of point is this? It's like, oh, well, I don't see the notches on the side. So they're not bisected. They're not perpendicular bisectors. So it must just be altitudes. It must just be height. So it's orthocenter. That's about the only questions you can get when it comes to orthocenter. So that one's nice and easy. But of course, the next one, centroid, is by far the most complicated. And it's got fractions, which is everyone's favorite. But I will help you with that too. So centroid is created by medians. A median is a line from a midpoint of side. Ooh. Line from midpoint of side to opposite angle. Okay, that makes a little bit more sense. My bad. Yeah, so a median is a line from an angle to a midpoint. Angle to a midpoint, angle to a midpoint. So let's say, let me mark the midpoints this time, right? So if I do the midpoint of the left side, we'll say it's right about here. Midpoint of the right side would be pretty parallel to that. Midpoint of the bottom should probably be dead smack in the middle, right? Midpoint, right? Cool. All right, so let's say we marked those midpoints. We're gonna mark them twice by saying that this side is equal to this side. This piece is equal to this piece, right? These notches are very important. They're what's gonna tell you which kind of line you're looking at. So make sure you're paying attention to them. So it is a line from a midpoint to an opposite angle. If I start here and I go to draw a line, well, I can't draw a line to this angle because that's a side, right? I can't draw a line to this angle, that's a side. So I have to draw a line to the only angle that I can basically reach. I'm gonna do that for each one. And it's gonna make a new point. That point is a centroid, and it is the most complicated of all, of course, right? All right, so that's the centroid. So that's how you make them, right? Those are the lines used to create them. That's the centroid. Unlike the other ones, though, this one has a lot of special properties, and it's really confusing. From the midpoint to the centroid is 1/3 of the line. From the angle to the centroid is 2/3 of the line. Huh? Let me explain what that means. From an angle, from the midpoint to the centroid. So if I go to any side's midpoint, and then I follow that line to the centroid, that is going to be 1/3. That is going to be 1/3 of the entire median. So if I went from the midpoint all the way to the angle, this is 1/3 of the line. From the angle to the centroid is 2/3 of the line. So the small part is 1/3, the large part is 2/3. Now I know everyone loves fractions. Fractions are everyone's favorite, right? I get it. No one likes fractions. And I'm going to teach you some really easy ways to do the centroid stuff. So if I labeled, we're going to do a practice problem right now because these questions pop up a lot. Centroid is the most tested of the 4. The other 3, you're going to get questions like, what kind of point is this? Or like with circumcenter, it's equal distance from the 3 angles. So you may see a question about, oh, from here to here is 5. What's the distance from here to here? Well, if it's from the circumcenter to an angle, then they're going to be equal. The other one's going to be 5 as well. You're going to see stuff like that. But centroid, you're going to see the most questions on. So let me label this point as A. Why not? We'll label the point down here as B. So let's say the question is AB equals 18. Why not? Now we need to find out what, I need to mark the centroid. Well, let's call it C, right? Centroid C. So if AB equals 18, let's say we want to find AC, and we want to find BC. We want to find the smaller parts of the whole thing. AB is the entire thing here. We want to find from here to here, so from A to C. Then we want to find from B to C. Now, centroid says that from A to C is 1/3 of the whole line. Okay, well, if the whole line is 18, we can figure that out. Pretty easily, too. So all you'd have to do is do 1/3. I'm going to draw it all out so you guys see everything because, why not? There we go. So it's going to be 1/3 times 18. And I'm going to teach you how to do this in a very, very, very easy way. Now, of course, times 1/3 is actually really easy, but let me show you this real quick. If you, what's the alt code for that? Hold on. Division symbol is 0247. All right, 0247. All right, so if you take a whole number times a fraction, all you have to do, make it nice and simple on yourself, you multiply by the top number, and then you divide, 0247, there we go, you divide by the bottom number. And the order doesn't matter. So long as you do both functions, you'll end up with the right answer. So 1 times 18 is 1, and then 18 divided by 3 is 6. That's 1/3 of 18. That's 18 times 1/3. So AC, 1/3 of the line, AC, equals 6. So once you do that, you can find out the other one pretty easily. You could do 18 minus 6 because the other part is what's left, right? But I want to show off, of course, math. You would do the same thing with 2/3. So I didn't do, because I got to select the line. All right, so 2/3. And it'd be 2/3 times 18, right? Well, we're going to fix that. And we're going to go 2/3. And we're going to decide, all right, well, we're going to do times by the 2. And then divide by the 3. Remember what I also said, the order doesn't matter. So if 3 goes into 18, you can divide first so you don't have to multiply big numbers, or so you don't have to divide into big numbers, but either one will work. If you did 18 divided by 3, you would get 6, and then you still have to multiply by 2, you would get 12. So you can do it that way. Or you could do 2 times 18, which is 36. And then you have to divide by 3. 36 divided by 3 is 12. That's how I suggest you do whole numbers times fractions. I find it really easy. Multiply by the top, divide by the bottom. It works every time. It works regardless of how large or small the numbers are. I remember I figured this out in the middle of a class, my first year teaching. And then I was like, oh my God, this is incredible. Why did no one teach me this? And then my students were like, okay, what a big deal. And I was like, no, this is a big deal. You should be impressed. They weren't, but I was. I figured this out. I thought it was really cool. It's very helpful. Whatever. So looking at the rest of this picture though, the centroid is always, from the midpoint to the centroid is 1/3. So midpoint to centroid is 1/3, which means from midpoint here to centroid is 1/3. And then from the angle to the centroid is going to be 2/3. I'm just going to label the whole triangle so you kind of get an image of it. From the midpoint to the centroid is 1/3 again. And then from the angle to the centroid is 2/3. Cool. This is one of the only times we actually deal with fractions in all of geometry, other than like, you know, test makers putting fractions in the problems. But, you know, we're going through it. We'll be fine. We'll be fine. So that's centroid. Centroid can be pretty complicated at first glance, but in the end, it's not that difficult, right? You're multiplying by 1/3 or 2/3. I mean, I don't want to complicate it any more than it is, but just to give you an idea, 2/3 is double 1/3. So 1/3 is half of 2/3. If you look here, 6 times 2 would be 12, because 2/3 is double 1/3. So once you know one of these sides, like once you know, like, oh, I know that AC is 6. Oh, okay, well then that times 2 is 12, and then add them up for the whole thing, 18. Cool. You'll be asked for centroid questions to find the whole thing, or to, you know, find bits and pieces of it. Like, it'll be all over the place. Centroid is huge. They use it a lot to, well, to question y'all. All right, last thing I want to go over, and I know there's one more thing, but the last thing I want to go over is the algebra that can be put in these kinds of questions. And algebra can definitely be put in these questions. So I'm going to draw one real quick. You can try and figure out before I tell you what kind of line it is, or what kind of point it is, my bad, as I give you more and more information here. So you can try looking up here at the lines used to create it to figure out what I'm drawing before I get there. And then this is going to be equal to this. This is going to be equal to this. And this is going to be equal to this. So we got our point here, right? All right, and then I have to do a ridiculous amount of labeling because, you know, why not? Nah, that's confusing. Q. We're gonna have triangle, DAB, triangle, dab on the haters. All right, sorry. Let's do V, W, E. Okay, so we got all these points on the triangle, right? We got the 3 angles labeled, we've got the 3 midpoints labeled, and then we've got this point in the middle labeled. Let's say the question was, I don't know, somewhere along the lines of, let's say, the distance from Q to D is, let's say, 5x minus 1. Yeah, 5x minus 1. The distance from Q to A is 5x minus 1. I gotta do the algebra in my head real quick. Hold on. 7x. Nah, I won't do that. Let's not do it that way. Let's do 3x plus. There we go. All right. So the distance from Q to D is 5x minus 1. The distance from Q to A is 3x plus 5. Solve for x. So I've been sparing you guys the algebra of geometry for a while now. They complicate a lot of questions with algebra, but you know, we gotta start doing it. I'm sorry. So let's start looking at what we're looking at. So from Q to D is the distance from here to here, and Q to A is the distance from here to here. Well, that's the distance from this point to the angles. Well, hopefully, you figured out what kind of point this is, right? Looking at these lines, that's a 90-degree angle. And then the side here is being cut in half. So this must be a midpoint. So this is bisecting the side at a perpendicular angle. It is a perpendicular bisector, which makes this point a circumcenter. And what's one of the properties of circumcenters? Well, they're equal distance from all 3 angles. Well, Q to D and Q to A are both distances to angles, right? Anytime you see algebra in geometry, all you have to find is an equal sign. Something is equal to something, and then you can solve. Whether it's like, you know, equal to 180 or equal to 90 or equal to each other, hint, hint, wink, wink, right? Equal distance from all 3 angles. Well, the distance from the point to the angle is going to be the same from any point or any angle to this point. So you know that 5x minus 1 equals 3x plus 5. So we can solve this. We can solve this pretty easily, right? So we'll go through this. Anytime you have an x on either side of the equal sign, first thing you should do is make sure there's no math you can do on either side. 5x minus 1, 3x plus 5, there's nothing we can combine. So then we move on. I always suggest move the smaller x. Anytime you have an x on either side of the equal sign, move the smaller one. 3x is smaller than 5x, and it's positive, so we're going to minus 3x from both sides. And then 5 minus 3, of course, is 2x minus 1 equals, these cancel out, and you're just left with 5. So now we got to do opposites, right? We've got x on this side here. We need to get it by itself. We don't want to deal with that 2 yet because it's too close to the x, right? You always move in from the outside inward. So negative 1 is farther away. Well, the opposite of a negative is a positive 1, right? Add 1 to both sides. 2x equals 6. And I know a lot of you are really good at algebra and you're like, all right, I got it, I figured it out. I know, man, I get it. But you got to make sure that everyone else gets it too. So I'm going nice and slow and showing every step. All right. So since 2 is being multiplied by the x, you're going to divide both sides by 2. Let's see if that worked. It did. Hey, look at that. So you divide both sides by 2. You're left with x equals 3. Your final answer. Boom. Nice. So that is the more complicated, or probably the most complicated that these questions are going to get. Is they're going to throw algebra at you. So you got to figure out what the point is, right? So the very first thing is, all right, what kind of point is this? Then what kind of special properties does it have? And how does that apply to the problem? Most of the time, it's either going to be centroid or circumcenter incenter if it has math involved, because orthocenter has no math. So it's always nice knowing you can just rule that one out if there's math involved. But yeah, there's quite a bit to unpack here. And I get that. I focused on the parts. I mean, of course, you guys have figured this. Most of you figured this out by now. I make the quiz, then I make the video. So I focus on what's on the quiz, basically, when I do these videos. So obviously, you're prepared for the quiz because I literally just went through the quiz and did examples from it. So you should be fine. But yeah, as always, if you have questions, message me. You know, I'm always available for Zoom tutoring throughout the day if you just ask for it. But otherwise, y'all have a great one, and I will talk to you soon. Peace out.